the simple argument that when you roll something at twice the velocity, and now we're going to pull all the energy out of both objects. So that's the test. We're going to take two things and they're going to have linear momentum, and all the linear momentum is substantially going to go into the ground. Yeah, there's some air resistance, but that's minor. Most all of the energy will be used pounding the ground. And the simple argument is the one going 2V will only produce twice the heat in the ground. That's all it's going to be in the ground. It's not going to be any more than that. It's not going to be 4 times the heat in the ground because it doesn't have 4 times the energy. It can't do 4 times the work. And so the same heat goes into the surface for 3/4 of the trip that goes into the ground in the last quarter, because the same weight will be on those two surfaces. And it's the weight that's creating the friction. And so it's a really simple argument, proves the case, frankly. And reasonable people should just accept that, frankly. Yeah, they should just accept that. Yeah, it's a damn good argument.
You've made this argument literally thousands of times now, but you never seem to clarify. But on that clip I've just shown, you have actually clarified what you say happens and what you think is the reality. So what you're saying is that over this 3/4 of the distance we'll have a temperature raise, and this 1/4 will be the same. So you are just literally adding the two together. You're saying there's twice the heat in the ground because this section is this temperature and this section is this temperature, and we just add them together. And therefore there's twice the heat in the ground, and that required twice the energy. But this is 3/4 of the distance. This is 1/4, so this is 3 times the distance raised to the same temperature as this. So we don't just add them together, because we've got 3 units of distance there and 1 there. So we've raised the temperature of 4 units of area. So if we have 1 unit of area and we want to raise that area to a temperature, it requires a certain amount of energy. If we then want to raise the temperature to the same as this, but now we've got 4 units of area, it takes 4 times the energy to raise that area to the same temperature as that. And that's what you're arguing for. You're saying that the 3 units of distance will be raised by temperature, and the 1 unit of distance will be raised by temperature. So if you break that down, we've got 4 units of area raised all to the same temperature, which requires 4 times the energy. So basically you're arguing for the correct thing for once. Well done.